Welcome to the Ontario High School video podcast. Really? You're that dense? We're going to talk about how to do density problems, how to solve for density when you're given the mass and volume of a substance. A very basic density definition is that the density of a substance is the amount of mass contained in a fixed unit volume of the substance. We often shortcut that to just say mass per unit volume. The mathematical relationship can be described as density is equal to the ratio of the mass to the volume, or mass divided by volume. And when we use symbols, we'll just say D is equal to M divided by V. For solids, we normally express density in grams per cubic centimeter. For liquids, we'll use grams per milliliter. And for gases, we'll use grams per liter. Let's look at a typical problem, finding density when we're given the mass and volume of the substance. What is the density of the substance if a mass of 14 cubic centimeters of the substance is 33.25 grams? There are several steps we'll do that will help organize our data and make it easier to solve. First, we're going to identify what we know from the problem and what we're trying to find out. We symbolize mass with a lowercase m. We know that's equal to 33.25 grams. Volume is symbolized with a lowercase v. It's equal to 14 cubic centimeters. What we don't know is d, which represents density. Once we have what we know and what we don't know written down from the problem, we can then go on to step 2, which is to write the base equation that relates density to mass and volume, and that is d is equal to m divided by v. Once we have the base equation, and in this case the base equation and our working equation are going to be the same. We don't have to do any rearrangements of the variables to solve. So we're going to put our mass of 33.25 grams divided by our volume of 14 cubic centimeters. We'll cancel any units if we can. In this case, however, we cannot cancel any units, so we'll carry the units through. 33.25 divided by 14.0 will give us 2.38 grams per cubic centimeter when rounded to the correct number of significant figures. Please remember, any calculation that you do in chemistry must have the correct significant figure protocol to get full credit. You've seen an example of how to solve for density when you're given the mass and the volume, so it's your turn. Here are 3 problems for you to do. What I'd recommend that you do is that you pause the podcast and work these problems out on a separate sheet of paper. When you've got your solution, come back, resume the podcast, and you'll see the solutions when the next slide appears. So if you'll go ahead and pause the podcast now and solve for these, I will see you back here in just a moment. Welcome back. Let's see how you did. The first substance was a 4 cubic centimeter metal sphere, and as you can see, we put the mass over the volume. The ratio of the mass to the volume is what density is. So 77.20 grams divided by 4.00 cubic centimeters. No units cancel here, so those carry through, and we get, when rounded, 19.3 grams per cubic centimeter. For part B, we have a liquid, so we're going to be operating in grams per milliliter. We have 130 grams divided by 10.00 milliliters, and we get 13 grams per milliliter. In case you're wondering how a liquid can be this dense, we're talking about mercury here. The other thing that you want to notice here is the 130 is 2 significant figures, and when we multiply or divide with significant figure related quantities, we have to report our answer in the same number of significant figures as the smallest number we have in the quantity, which would be 2, so that's rounded to 13. For part C, we're finding the density of a gas, so our mass is 20.85 grams. We're dividing by 15.0 liters, and we get 2.38 grams per liter. If you had trouble doing these, I would recommend that you go back in the podcast, rewatch, and then try these problems again on a fresh sheet of paper so you can't see what your answers were before, and see if it's easier this next time around. Well, we have come to the end of part one of the density series of podcasts that we're doing here at Ontario High School. I want to leave you with a quote by one of America's most famous generals. If everyone is thinking alike, then somebody isn't thinking. So, goodbye.